Okay, so 4.6 number 7. 4.6 number 7 says determine whether Rolle's theorem applies to the function on the given interval. If so, provide the points that are guaranteed to exist by using Rolle's theorem. So first off, let's go back to what Rolle's theorem says. Rolle's theorem says that if I have a function, it doesn't matter what that function really looks like, but if the endpoints are equal, like here and here, regardless of what that function looks like, there's guaranteed to be a point where the derivative is 0, as long as this is equal to this. So these are equal, there's guaranteed to be this point where f prime of x equals 0. Okay? So in order to determine if Rolle's theorem applies, we have to make sure that the endpoints are equal, and we have to also make sure that the function is continuous in there. So first of all, if I take f of, let's just do f of 0, right? So the endpoint 0 here, 0 times something is 0, or 1. So if I do like f of 0, I get 0 times 0 minus 1 squared. Well, that equals 0, because 0 times anything is 0. And if I do f of 1, I get 1 times 1 minus 1 squared. 1 minus 1 is 0, 0 squared is 0. That's also equal to 0. So because the endpoints are equal, and assuming the function is continuous, and we could graph this real quick using Desmos and determine that the function is continuous from 0 to 1. Sure looks like it's continuous from 0 to 1. So we're good there. So because those are true, we know that Rolle's theorem applies. So step number 1 was Rolle's theorem applies. Okay? So what that means is there's guaranteed to be a point between those two, and it actually looked like this when we looked at it, when it went between 0 and 1. Here's 0 and here's 1. But it doesn't matter. The step 2 now is to find that point. All right? So we need to find f prime of x, and then set it equal to 0. So f prime of x is going to involve looks like a product rule, x times x minus 1 squared. So let's see, product rule, f prime of x, g of x, plus f of x, g prime of x. Okay, so if I take the derivative, let's see, the derivative of the first term, leave the second term alone, x becomes 1 times x minus 1 squared. I'm going to add that to leave the f of x alone, the x, and take the derivative of the second term. So this becomes, must become 2 times x minus 1. So 2 times x minus 1. Okay. Then let's narrow that down a little bit. F prime of x equals 1 times x minus 1 squared just becomes x minus 1 squared. X times x is x squared. Minus x is minus 2x. And then minus 1 times minus 1 would be plus 1. And over here I get a 2x minus 2 times x, though, becomes 2x minus 2. So it's 2x squared. Minus 2 becomes minus 2x. That looks pretty good. Take f prime of x a little bit further, see if there's anything I can combine here. That becomes a 3x squared minus a 4x plus 1. Oh, and guess what we're going to do with that? Minus 3x squared minus 4x plus 1. That might factor, I'm going to guess. Let's see. And you could use a quadratic formula here. Let's do a 3x and an x to get my 3x squared. Is this minus 1 and minus 1? Minus 1 and minus 1. So 3x squared minus 3x minus x is minus 4x plus 1. That's perfect. So in this case, there's two possibilities here that are going to give me a 0. Okay, so both of these are considered 0. The first one would be x equals 1. Okay, well that's an endpoint. So Rolle's theorem says I'm looking for something in the middle here, right? This x equals 1 is actually an endpoint, so this is not in my solution set. I need something in the middle. Hopefully this one's not 0. So let's solve this one. So let's set 3x minus 1, set that equal to 0. And we get 3x equals 1, x equals 1/3. X equals 1/3 is in my solution set. We know the endpoints are 0, so this can't be my answer. Rolle's theorem guarantees there's something in between these two. X equals 1/3 looks like it's my answer. And you can always, always, always verify these answers by going into something like Desmos and saying, is this point right here where the 0 is it 1/3? Absolutely it is. If I zoom in on this a little bit, I can see that that point where it's 0 is x equals 0.333. So you can see the power of both Rolle's theorem and the derivative.